For section 7.2, we're looking at the addition and subtraction formulas. The identities are on your identity sheet. I also posted a quick little PowerPoint of a little Jingle Bells version to help us memorize these. So I'm going to sing this Jingle Bells version and we'll talk through it as we go through. So addition, subtraction, cosine flips the sign. Sine is mirrored, it keeps the sign while you double for cosine. So what does that mean? Addition, subtraction, that's the identities we're talking about. Cosine flips the sign. Notice that on your cosine identity, it goes from plus or minus to minus or plus. What that means is if you're doing cosine addition, it will switch to subtraction. If you're doing cosine subtraction, it'll switch to addition. Sine is mirrored. What do I mean by that? Notice that the identity goes sine, cosine, cosine, sine. So like there's like a vertical mirror reflection kind of thing happening here. It keeps the sign. Sine keeps the sign. So if it's positive, it will be positive. If it's negative, it will be negative. While you double for cosine, I don't mean 2 times cosine. I mean it goes 2 coses, cos, cos, 2 sins, sin, sin. The big thing to remember with these identities is that you don't distribute the trig through. So it's not like I would say, oh, the sine of x plus the sine of y or something like that. You don't distribute a function. It doesn't make any sense. Tangent is also here, but I'm not going to have you memorize that one. So you're responsible for sine and cosine on a quiz or exam. Tangent, I will give you if it comes up. So let's apply these identities. On these first ones, we're trying to find the exact value, but 195 is not one of my normal angles. So what I want to do is split 195 into angles that I know. Well, one way I could do this would be to call it 150 plus 45. That adds up to 195, and I do know those angles. Those are some of my normal angles around the unit circle. Now, again, I don't distribute sine through. That's not how this works. I have to apply the addition identity. So addition, subtraction, cosine flips the sign. Sine is mirrored. So that means this is going to be sine of the first thing, cosine of the second thing. Sine is mirrored. It keeps the sign. So it was positive, so it's going to stay positive. So the mirror is that now it's going to be cosine of the first thing, sine of the second thing. So it looks a little cumbersome, but all of these I can calculate. The sine at 150, sine is positive in the second quadrant. It's a half. The cosine of 45 is root 2 over 2. The cosine of 150, cosine is negative in the second quadrant. That's negative root 3 over 2. The sine of 45 is root 2 over 2. So now I'm going to multiply both sides together. Well, each side individually together. So that's going to give me root 2 over 4 plus, well, actually, sorry, it's going to be minus because I have a negative there. So minus root 3 times root 2, that's root 6 over 4. Now, all I can do, I cannot actually subtract root 2 minus root 6, but since they both are over 4, I can write them as a single fraction. So root 2 minus root 6 all over 4. That is an exact answer to that. So again, at no point did I just distribute sine to both of those. Please don't do that. I always have some students do that every semester. It is definitely not correct. For letter B, well, first thing is I can apply, to make this a little easier, the even odd identities In particular, the fact that cosine of a negative, we go back to our identities. Let's see here. There we go. Cosine of a negative, remember, since it's even function, the negative goes away. So I can just call this the same thing as cosine of 11 pi over 12. So I don't have to really think about that negative. Now, you can leave it in radians, but it might be easier to convert that to degrees. So you could do the whole multiply by 180 over pi, or if you think about it, on the unit circle, 5 pi over 6 is 150. 6 pi over 6 is 180. Well, that's really 10 twelfths and 12 twelfths. 11 twelfths would be right in the middle. So right in the middle of 150 and 180 is 165. So this is really saying the same thing as the cosine of 165 degrees. So I used the even identity and I converted it to degrees. So now I've got to think, okay, what are two angles that combine with either addition or subtraction to give me 165? And again, I want it to be two angles that I know. So an option might be, let's say 120 plus 45. That adds up to 165. So now I can apply cosine's identity. Addition, subtraction, cosine flips the sign. That's going to become a negative. Sine is mirrored, it keeps the sign while you double for cosine. So that means it goes cos, cos. So cosine, the first one, 120. Cosine, the second thing, 45. Sin, sin. Sine, the first thing, 120. Sine, the second thing, 45. Oops. Come on back. There we go. There we go. So I turned this into angles that I know. Cosine at 120 is negative a half. Cosine 45 is root 2 over 2. Sine of 120 is root 3 over 2. Sine of 45, root 2 over 2. So I'm going to end up with negative root 2 over 4 minus root 6 over 4. 6. And again, I can push the numerators together, but I can't actually combine them necessarily. And so I end up with negative root 2 minus root 6 all over 4. For letter C, tangent, and again, tangent you do not have to memorize, but you need to be able to use the identity. I'm going to use the odd function identity for tangent. The negative doesn't go away like it did on the cosine, but the negative can be brought out. So this is the same thing as bringing the negative out in front of it. So negative tangent. And again, I would suggest turning that pi over 12 into a degree instead of a radian. Pi over 12 is 15 degrees. So this is negative tangent of 15 degrees. All right, so now I have to somehow turn 15 degrees into two angles that I know. Now there are options here. The one I'm going to use is 60 minus 45. You could have also used 45 minus 30. It would have been a little bit more different work, but you would have ended up with the same answer. Okay, so now I have to apply tangent's identity and realize there's going to be a negative out in front of this the whole time. So tangent is a fraction. So it's tangent, the first thing, minus tangent, the second thing. Now, if you notice on your identity, it has a plus or minus here, but then down here it has a minus plus. That means switches signs. So down on the bottom, it's going to be 1 plus tangent of 60, tangent of 45. Okay, so this would be negative. The tangent at 60 degrees is root 3. The tangent of 45 is 1. And then down here, this would be 1 plus root 3 times 1, which is just root 3. Okay, that's it for the trig part. Now I'm just going to do some algebra to clean this up. I'm going to multiply by the conjugate of the denominator. The conjugate of the denominator would be 1 minus root 3. So this is going to turn into, I still got a negative out in front. Get that out of the way. On the top, I'd have root 3. If I FOIL the top, minus 3 minus 1 plus root 3. On the bottom, since I'm multiplying by conjugates, I can just FL the bottom. First times first would be 1. Last times last would be minus 3. So at this point, I'm at, there's still a negative. On top, I have negative 4 plus 2 root 3. I have a root 3 plus a root 3. On the bottom, I have negative 2. I can reduce this. Still got the negative out in front. 2. Reduce this to minus root 3. Now remember that negative was out in front of all of that. And so the final answer, negative 2 plus root 3. So algebra part of that definitely took some more work. But the big concept is applying the identity. Again, we don't just distribute tangent through. You cannot do that. Number 2, A and B are much simpler. I'm showing you basically the expanded out identity. We're going to try to condense it back down. So on this one for 2A, it's going cos, cos, sin, sin. That looks like cosine's identity. So this is going to condense. So we're basically going from right to left on these. This is going to condense into the cosine of two things. And now the question is it added or subtracted? Well, cosine flipped the sign, so it's going to become a plus 26 plus 94. So this turns into the cosine of 120 degrees, which is just negative a half. For letter B, it goes sin cos, cos sin. That looks like sine. Sine keeps the sign, so it's going to stay minus. So it's 11 pi over 12 minus 2 pi over 3. If you get common denominators, that becomes the sine of 3/12 or the sine of 1 pi over 4, which is root 2 over 2. For number 3, we're given some information. Notice these are not going to be our normal 30, 60, or 45 angles because our cosine and tangent here are weird numbers. These are going to be ones we're going to have to draw out a triangle. This is what we want to know, the cosine of theta minus, that's phi, by the way, P-H-I, but pronounced phi. So the cosine identity. So this thing, write this over here. Addition, subtraction, cosine flips the sign, so I know it's going to turn into plus. Sine is mirrored, it keeps the sign while you double for cosine. So this goes cosine the first thing, cosine the second thing. Plus sine the first thing, theta, sine the second thing, phi. Okay, well, what do we know right now? The only thing we know so far is the cosine of theta. So I can plug that in. That's negative 3/5. I need to figure out the sine of theta eventually. So I'm going to use this given information. I'm in quadrant 3. I'm just going to draw some random triangle to the x-axis such that its cosine is 3/5. So remember, from my reference angle, the cosine, the adjacent, is 3, the hypotenuse is 5. By Pythagorean theorem, your missing side is 4. So the sine of theta, we're in quadrant 3, sine is negative down here. The sine would be opposite over hypotenuse. So the sine of theta is negative 4/5. Okay, now that's it for theta. Now we're going to look at angle phi. I'm given the tangent of phi, and I'm told that I'm in quadrant 2. So again, I'm going to draw just some generic triangle in quadrant 2. If the tangent is root 15, I can think of that as root 15 over 1. So that would be root 15 for the opposite, 1 for the adjacent. If you do Pythagorean theorem, you'd end up with the hypotenuse is the square root of 16, which is 4. And so now, from my reference angle, the cosine of phi, adjacent over hypotenuse, is going to be negative, because cosine's negative in quadrant 2, 1/4. The sine of phi is going to be opposite over hypotenuse. Sine is positive in quadrant 2, so that's going to be root 15 over 4. That's a positive on that root. So I got every piece, just like I did on the previous problems. I'm going to multiply them together. So this is going to be 3/20. It's going to be plus, but there's a negative, so minus 4 root 15/20. And really all I can do is just put them together and call it 3 minus 4 root 15 all over 20. So I had to build triangles and find missing sides because I was not dealing with 30, 60, or 45s. For the last 2 problems, we're going to do some proofs. Now, these actually will go quicker than a lot of the stuff we did in the previous section. Again, remember, cosine, I don't just distribute this through. I have to apply the identity. So I'm going to take the left side. I'm going to apply cosine's identity, which is going to be cosine of the first thing, cosine of the second thing. Cosine flips the sign, so it's going to become plus sine of the first thing, sine of the second thing. All right, now I don't know anything about angle x, so I can't do anything with that. But pi over 2, I know that angle. Pi over 2 is 90 degrees. The cosine at pi over 2 is 0. So this is 0 times the cosine of x, 0 times the cosine of x, plus the sine at pi over 2 is 1. So 1 times the sine of x. Well, cosine x times 0, gone. 1 times sine x is sine x. Hey, looky there, that's what I wanted. The proof's done. So basically, I just applied the identity, and the answer fell out of the problem. For letter B, I'm going to work on the right side because this is an identity, or I can apply the identity. So tangent, it goes tangent, the first thing, plus tangent, the second thing, over 1, switch the sign, so minus tangent, the first thing, tangent, the second thing. Well, the tangent of pi over 4 is 1. So this would be 1 plus tangent x over 1 minus, I would have, again, tangent of pi over 4 is 1. 1 times tangent x. And looky there, that's what I was going for. The proof is done. So again, make sure that you know for the quiz and exam, sine and cosine's identities. If tangent comes up, I will give it to you, but you've got to know sine and cosine.